Hello everyone, I am Serter Solak, and it is a pleasure to presenting this presentation with you today. When we gather like this, I am reminded of the power of connections and the opportunities they bring. Allow me to introduce myself and share a bit about my journey. I am an entrepreneur and visionary and lifelong learner. I am always seeking new ways to innovate and make a positive impact on the world around me. With a background in data engineering, I have had the privilege of working on various projects and collaborating with the talented individuals from diverse backgrounds. Throughout my career, I have been driven by a passion for excellence and the determination to push the boundaries of what is possible. Whether it's building and managing successful startups, mentoring inspiring entrepreneurs, or supporting causes close to my heart, I have always strived to make a difference. You may have seen my LinkedIn profile also that I have been involved in projects related to advanced visualization. This experience have not only shaped my professional journey, but also reinforced my belief and transformative power of the determination, collaboration, and innovation. But beyond the awards and accomplishment, what truly motivates me is the desire to make a meaningful difference in the life of others. I am committed to using my skills and resources for the greater good, whether it is creating jobs, supporting charitable causes, or empowering individuals to pursue their passions. As I stand before you today, I am excited about the possibilities ahead and the chance to connect with like-minded individuals who share my vision for a brighter future. Together, I believe we can overcome challenges and opportunities and create a world where innovation thrives and everyone has a chance to succeed. Let's get started with the presentation, advanced visualization techniques for complex data. And then my first slide is my introduction. Firstly, today's topics are type of the data visualization, interactive visualization with the visualization large data set in this combined, and the data visualization best practices. By the way, the introduction of heading, I want to give importance of benefits visualization. For example, the first heading is enhanced understanding. Visual presentation of the data make complex information more accessible and understandable. Charts, graphs, maps provides and clear insights to trends, patterns, and relationships within the data, allowing for the better comparison and the analysis. But the second heading is increased engagement. This means the visualizations are more engaging and memorable than the raw data and textual information. They capture attention and facilitate the communications, leading to the greater engagement and the retention of information among the audience. And the third heading, I mentioned the efficiency of the communication. So visualizations serve as a universal language that transcends the barriers such as language and expertise. They enabled efficiency communication of the couple of ideas and the facilitating collaboration and the knowledge sharing among the diverse audiences. This is the main item of the efficiency of the communication. At the fourth header is the faster insight, I think. At the visual presentation of the data enable faster insight and understanding compared to traditional data analysis methods. With an interactive visualization, user can dynamically explore the data, drill down, drill out into details, and gain real-time insights. It's accelerating the decision-making process also. And the fifth heading is storytelling is the most important one, I think. For the storytelling is data visualization allows for the complete the storyteller by the presenting data in a narrative format. Visualization helps convey the story behind the data, evoke emotions, persuade the audiences to take action based on the insight presented. This healing is more important for the time because best practices becomes more important. I'm going to the next slide for the types of data visualization. Pie charts and histograms, lines, area charts, Gantt charts, network diagrams, tree diagrams, scatter plots, all are the data visualization types. If you are in process of trying to build a story, persuade a group of people, or better understand your data, consider creating some sort of visual presentation to guide your truths and truths of the others. So these visualization types are become more important to tell this story. What is the most popular one, do you think? Bar graphs and pie charts more important and the most popular ones. Relation types. The other forms, line graphs, histograms, pivot tables, explodes, scatter plots, radar charts, bubble charts are the others one. And so I'm going to my next slide. Interactive visualization refers to use to dynamic, user-driven feature in the data visualization to facilitate exploration, analysis, the understanding of the complex data sets. Some benefits of the interactive visualization focusing on how it enables users to highlight the keys and explore or maybe filter the data. I will mention some important points of benefits interactive visualization. Firstly, enhance of the engagement, I think. Interactive visualizations captive users' attentions and encourage active participation by allowing them to interact with the data in real time. It's important, I think. The second one is the deeper understanding. Users can delve deeper into a data and gain a better understanding of the patterns, trends, and relationships by the interactive exploring different aspects of the data sets. It's the important, second important one. Third one is the customized insights, I think. Interactive visualization empower users to customize their analysis, selecting, filtering, and manipulating the data or focus on specific area or interest or relevance. And efficient communication. It is easier to communicate complex insights by allowing users to interactively explore the data or discover the key finds at their own also. And maybe users alternatively refine their analysis and hypotheses by dynamically adjusting visualization parameter, exploring alternative views, and testing different scenarios. Users also actionable decision making by the interactive visualization. For the data-driven decision, it's more important making by providing end users with actionable insights and enabling them to explore various options and outcomes interactively. Highlights about key insights I'm going to mention. For example, interactive visualization allows users to dynamically highlighting key insights by adjusting visual elements such as color, size, shape, or opacity, and to draw attention to important data points or trends. Users' annotation is important also. They can add interactive annotations and labels or tooltips and specific data points to the region of the interest to provide context and convey key insight efficiently. Focused and empathy is another feature that enables users to focus on a specific area of the data by zooming in or zooming out or panning or filtering out irrelevant information, making it easier to identify and interpret key findings. And enabling user interaction, the third action. Enabling for user interaction is exploring and filtering data. Filtering a section or the interactive visualization allow users to filter and select specific data point, category, or the time period of the interest. enabling them to focus on relevant subsets of data. And also drill down and drill up. Users can drill up into detailed data or the higher level summary or lower level summary by interacting with the hierarchical visualization or using interactive navigation controls for this item. Sorting and ranking is the more important for the interactivity feature because it enables users to dynamically sort and rank data based on different criteria such as value or alphabetic order or frequency or identify the top performer, outlier or trends. And another thing is the exploratory of the analysis. Interactive visualization support the exploratory analysis by using users to dynamically change visualization type and adjust the parameter, experiment with the different view to uncover hidden patterns or relationships in the data. So, interactive visualization empowers users to engage with the data in meaningful ways, enabling them to key insights and highlighting key insights, explore and filter data efficiently, and derive actionable insights and make informed decisions. This interaction visualization is the most important for the large data sets. And my next slide is may focus on presentation visualization, the technique for the complex data presentation. In our increasing data-driven world, the ability to make sense of vast amounts of data is paramount for informed decision-making and extracting valuable insights. We should delve into various techniques that enable us to tackle the challenge of the visualizing large data sets effectively. We should explore how these methods help us distill the complex data into meaningful presentation. For example, sampling and aggregations are foundational techniques that allow us to extract relevant insights from large data sets efficiently. By selecting a subset of data points and combining them into a summary of the statistics, we can capture the essence of the entire dataset while reducing the computational overhead. And so we should think about the reduction and the summarization of technique. These methods enable us to decrease the volume of data while retaining essential features. Whether through the principle component of online or summarization statistics like median, we can still complex data into a consistent representation. But what about the handling high-dimensional data? That is where the data clustering and dimensionality reduction come into play. That is where the clustering and the dimensional reduction come into play. Clustering techniques. Clustering techniques help us group similarity data point together. While dimensionality reduction method can enable us to visualization high dimension model into lower dimension space, this approach empowers us to explore and understand complex data structure more efficiently. And lastly, I should explore hierarchical and nested visualizations that provide a hierarchical view of data and allow for drill-down exploration. Tree maps, nested pie charts, visualizations offer insights into relationships and structure with the data, enhancing our understanding of complex data sets. Correlation. Visualizing large data sets requires a multi-phase approach by employing techniques such as sampling, aggregation, data reduction, clustering, dimensionality reduction, and hierarchical visualizations. You can unlock valuable insights to drive informed decision making for this. Let's talk about the main subjects of this slide. Sampling, the first one is the sample and aggregation technique. And this is the first. Sampling involves selecting a subset of the data point from a large population to present the whole. There are various sampling techniques which suited to different type of the data and analysis goals. Also, random sampling, for example, involve selecting data points randomly from the population, ensuring that each data point has an equal chance of being selected. The approach is useful when the population is homogeneous and no specific pattern or structure to consider. Stratified sampling, on the other hand, involves dividing population into distinct strata based on certain characters. For example, age, gender, location, and the sampling of each stratum separately. Approach ensure that each subgroup of population is adequately represented in the sample, making it useful when there are significant variation within the population. Once we have our sample, we can use aggregation technique to summarize the data and extract meaningful insights. Aggregation involves combining multiple data points into summary statistics or aggregates. Yes. For example, we can calculate the average or count of a certain variable in the sample to get an overall picture of its distribution or behavior. Aggregations help us to reduce the complexity of the data while observing important trends and patterns, making it easier to analyze and interpret. The second one is data reduction and the summarize. This one. Reduction technique aims to decrease the volume of the data while retaining its essential features. One common approach to data reduction is dimensionality reduction, which involves reducing the number of the variables and the features in the dataset while preserving its essential structure. The principle of the component analysis is a popular dimensional reduction technique that identifies the most important access variation in the data and takes to a lower dimensional space. Another approach to data reduction is feature selection, which involves selecting a subset of the original features that are most relevant to the analysis. And features selection methods can be supervised or unsupervised, depending on the whether they can into account the target variable in the dataset. Once we have reduced the dimensionality of the data, we can further summarize it using various techniques, summary statistics, such as median, standard deviation, and percentiles, provide insights into a central tendency, breadth, and distribution of the data. And histograms, box plots, and plots are graphical presentation that visualize the distribution of the data and have identity outlier trends and patterns for the data reduction and the summarization. And the third one is using data clustering and the dimensional reduction. The clustering techniques group similar data points together based on their features and the attribute. Clustering helps us identify natural patterns and structures within the data, such as cluster of the customer, filler buying behavior, for example, or clusters of the genes are similar expression profiles. There are various clustering algorithms, including k-means clustering, hierarchical clustering, and the density-based clustering, each suited to different type of the data and the analysis goals. Dimensional reduction technique transforms the high-dimensional data into low-dimensional representations while preserving its essential structure. These techniques are particularly useful for visualizing high-dimensional data in 2 or 3 dimensions, making it easier to explore and interpret complex data sets. And the fourth one, nested visualization. This represents data in a hierarchical structure where elements are organized into unchained relationship. Visualization provides a natural way to explore hierarchical data structure, such as organizational and maybe listed categories or taxonomies. Also, remaps, onboard charts, and dendrograms plots are examples of the hierarchical visualization that help us visualizing the relationships between different levels of the hierarchy and identity pattern, and also structure within the data. Nested visualizations display the data within multiple layers of the nested structures, allowing users to explore relationships at the different level and the different granularity. These visualizations provide a hierarchical view of the data while enabling drill down and drill down exploration. Nested pie charts, nested bars charts, and nested tree maps are the example of the visualization that help us visualizing the complex data structure and uncover insights at the different level of the abstraction. This is the visualization highlights I mentioned. I'm going to go to the next slide also. And the data visualization best practices. First, heading is your audience. This is the important one. Understand who will be viewing your visualization. Tailor them to their level of expertise. It is important for practice because you must know your audience. And the second one is right visualization. Right visualization tool, right visualization technique is much more important after the audience. It is the visualization that efficiently communicate your message and highlight the pattern and trends in your data. Consider factors such as the data type and the message you want to convey. Audiences familiarity with the different visualization types is the best choice. And the third one, tell a story interactively and structure your visualization to this story way that has a clear and compelling story, the flow maybe, and narrative arc, and to guide viewers the data. And highlighting key sites also important, and trends of the way also. And the fourth one is simplify and clarify. And please keep your visualization simple and focused, avoiding a cluster and unnecessary elements. Use clear labels, annotations to help viewers interpret the data accurately. And the conclusion of my presentation is about me. At the end of my presentation, I have a key takeaways. It is so important, clear data for good information. This one. And second, storytelling for the best concept. And the third one is goal. more functionality, for the more function based. And the third one is a visual form for metaphor, for the best metaphor. These items are the none of the successful data visualization narratives aware of these items. As I lead our presentation of advanced visualization techniques, important to recognize that journey is ongoing. Knowledge and insights gained us assist in the boundaries of the capable utilizing visualization to unlock the full potential of complex data sets. Send my sincere gratitude for engagement and attention throughout this presentation, and have a wonderful day. Goodbye. Thank you.